Welcome to the section on applications. We're going to do a number of problems. First one says, length of an escalator. How long should an escalator be if it is to make an angle of 33 degrees with the floor and carry people a vertical distance of 21 feet between floors? So the 21 feet here for the height would be the opposite of the angle A, and we're supposed to determine the length of the escalator, which would be the hypotenuse, so we're going to use the sine. Sine A equals h over the length of the escalator. And then the length of the escalator is going to be h divided by sine A, which means 21 feet divided by sine of 33 degrees. Copy the degree sign in there, and I'll do this on the side. 21 feet divided by sine 33 degrees is almost 1/2. Dividing by 1/2, we should come up with roughly 42 feet. So let's see if that's true. 21 divided by sine 33 degrees, 38.5 feet, or around at 39 feet. Relatively close to my estimate from a moment ago. The image here is from a website called flickr.com, where we can use the images without having to pay or without violating copyright issues. So all the images that you see here are from that website. Okay, the next one says, length of a rope. A 72.5 foot rope from the top of a circus tent pole is anchored to the ground 43.2 feet from the bottom of the pole. What angle does the rope make with the pole? Assume the pole is perpendicular to the ground. So this rope here is 72.5 feet long, looks like the hypotenuse. This distance here is 43.2 feet, and the angle is from the rope that the rope makes with the pole. So the pole would be here, so it's this angle up here. So we have given the opposite down here and the angle up here. So we're going to have sine A equals D over L, or angle A equals inverse sine of D over L, which is 43.2 feet, divided by 72.5 feet. The units cancel, which is good because when we take the inverse sine of a number, that number cannot have any units. So again, I'm going to do this on the side. Inverse sine 43.2 divided by 72.5, and I come up with 36.6 degrees. And looking at the significant figures here, that's the way it should be rounded. Let's see, I'm going to copy a degree slide from somewhere. Next exercise. Which says, angle of a ladder. A ladder is leaning against the top of a 7.5 foot wall. If the bottom of the ladder is 4.5 feet from the wall, so this distance here, and the wall is 7.0 feet high. This looks almost to scale here. What is the angle between the ladder and the wall? So what they're looking at is this angle up here, which makes the wall the adjacent and the bottom on the ground here the opposite. So we're going to have tangent A equals, and then this one here is the opposite, D over H. Respectively, A equals tangent, the inverse tangent of 4.5 feet divided by 7.0 feet. And again, I'm going to do this on the side. That's going to be the inverse tangent of a number that's less than 1, so we should come up with less than 45 degrees. tangent, inverse tangent of 4.5 divided by 7.0. 32.7 degrees should be rounded to two significant figures, 33 degrees. And remember, that's the angle up here, 33 degrees, which means this angle down here would have to be 57 degrees. Okay, next exercise, distance and bearing. Okay, it's going to be interesting here. It says, a boat leaves the harbor entrance and travels 25 miles in the direction north 42 degrees east of north. The captain then turns the boat 90 degrees and travels another 18 miles in the direction 48 degrees east of south. So that's this one here. At that time, how far is the boat from the harbor entrance, and what is the bearing of the boat from the harbor entrance? Because the captain turned the boat by 90 degrees, we know that we have a right triangle here, or a right angle here, and we're supposed to find the distance. So what I'm going to do here is I'm going to put another line in here. There we go. So we can just use the Pythagorean in order to come up with the total distance. So the Pythagorean means that the total distance d equals lowercase d. There we go. Is the square root. I have to borrow the square root from somewhere. Of 25 miles squared plus, let's see if I can take a square from somewhere. No, I can't. So there's the square. Plus 18 miles squared. And I do this on the side. 25 squared is 625 plus 18 squared, 324 is 949. Take the square root of 949. That's going to be a little more than 30. Yep, 30.8. And I guess it should be rounded to two significant figures. There are 31 miles. Should be the right answer. That's the distance. What's the bearing? Well, we're going to do a little trick here. We're going to say we already know this angle here as 42 degrees, and so we determine what this angle here is, and we add it to it. Well, we have a triangle given. If this one is an angle, then we can use, for example, cosine of that angle, and I may call it angle B, is the adjacent, which we know, which is 25 divided by the hypotenuse, which we just determined, to 31. So that angle B comes out to the inverse cosine of 21 over 31. Let's see, the inverse cosine, and again I do that on the side, 25 over 31. I come up with 36 degrees. So this angle here is 36 degrees, which I will add to the original 42 degrees, this angle here. So we're going to come out that the bearing is 42 plus 36, which is 78 degrees. And then I should write that that is 78 degrees east of north. Okay, next problem says height of a flagpole. Two people decide to estimate the height of a flagpole. One person positions himself due north of the pole, and the other person stands due east of the pole. if the two people are the same distance from the pole and 25 feet from each other, find the height of the pole at the angle of elevation from the ground to the top of the pole at each person's position as 56 degrees. I couldn't replicate the drawing from the book, so this is just the same drawing or image that you had from the the same image from the lecture that I gave. This here would be the flagpole, so we're looking from the top here, and then we have 25 degrees, and it says they're standing both the same distance. Of course, I'm questioning why didn't they just measure their own distance here. But in any case, we have 45 degrees angles here, so in order to come up with this distance here, all we would have to do is take 25 and divide it by the square root of 2. So 25 divided by the square root of 2, and we're going to come up with that this one here is around at 18 feet from the flagpole each person. So A equals B equals around at 18 feet. We know that from 45-degree angle triangles. Now we're going to go over here. Now we're going to go into vertical, and we're saying that this angle here is 56 degrees. And this distance here is 18 feet, and we're supposed to figure out what the height of the flagpole is. Well, we have given the adjacent. We're supposed to determine the opposite, so we need the tangent. So tangent of A prime, I call this A prime, equals the height of the flagpole divided by A. And then we're supposed to come up with the height H, and that equals A times, so I have to borrow times from somewhere. There we go. A times tangent of A prime, and that is, let's see, 18 feet, times tangent of 56 degrees. And again, I do this on the side, so 18 times tangent 56. Doing it on the side means that I don't have to bother switching forth and back between Word and the graphing calculator. So around it 27 feet. For some reason the book says 26 feet. Oh, I know why that is, because earlier when I rounded the 18 feet here, if I left it, and maybe that's actually advisable to leave it, not round it, but take the intermediate result as many decimals as possible, 17.677 and so on feet. And if I plug in that number, actually, then we come up with around it, let's see, 17.6. 77669, actually it says, and I do actually come up with the 26.2 feet, so around the 26 feet rather. So this one here should not be rounded that much. And the last exercise, which says radius of the Earth. The satellite is circling 112 miles above the Earth, as shown in Figure 21. I'm going to scroll this down here so you can still look at the last exercise if you want to. So, satellite circling 112 miles above the Earth, as shown in the figure. So here is the 112. I'm not sure how good that looks like in eLife. When a satellite is directly above point B, angle A is found to be 76.6 degrees. And notice in the book, as well as my drawing, that's not quite to scale. It's really tough to do that because the distance is actually rather small compared to the radius. Use this information to find the radius of the Earth. Whoa, let's see what happens here. Well, what we have is that this side here, which is the adjacent to the angle is of no consequence. We don't need to know it. So let's see what we can do with the opposite as well as the hypotenuse. Opposite, of course, means sine of the angle. Let's see, I think they call it angle A. Sine A equals the opposite, which we don't know, it's the radius r, divided by the hypotenuse, which is the radius r plus 112 miles. Looks like quite some algebra. Let's actually just plug in the 76.6 degrees here. So sine of 76.6 degrees, which comes out to 0.9728 rounded, and that equals this one here. And then unfortunately we do have to do some algebra here, so it's going to be 0.9728 around it again, times, I'm going to borrow times here, times this parentheses, equals the radius r, and continuing with the algebra, that's going to be 0.9728 times radius r plus 112 times 0.9728. I'm going to do that on the side. I'm going to use all significant or all decimals that I've given on my calculator. 108.95 equals r. Then we subtract this one here on the left-hand side, and the algebra really is that long, minus this one. So we're going to come up with 108.95, and then 1 minus 0.9278. And again, I'm going to try to use actually the original 1 minus sine of 76.6 degrees. So we're going to come out with 108.95 equals 0.02722 times r. So r equals 108.95 divided by that small number, 0.95 divided by 0.02722. I know what the outcome should be. Where in miles it should be pretty close to 4,000 miles. In fact, that's what I come up with. R equals 4,002 miles. And at that point, actually, I did skip a few decimals or significant figures at times, and the answer is really, really close to 4,000 miles. This is what my calculator gives me at this point here, so I'm going to leave it at this. You did see it take longer because the algebra is a little bit more involved, simply because the variable that we're supposed to solve for, the r here, appears in two different places, so we have to solve for it. But that's what you learn in college algebra, and so you should be confident that you can do that. That concludes the problem section for this section on applications.